but let's get to the main topic for today. So in previous lessons, we've been talking about powers of exponents. And one thing I want to start with today is I just want to make sure you know how to go between power and root form. So I want to ask you, if I give you x to the power of a third, that is written in power form. Can you write that in root form for me, or radical form? So I want you to, I can zoom in, I can try it a little bit. In fact, let me give you an example. So x to the power of a third is the same as the cube root of x. Now, if I had, or if I use numbers, I could say 8 to the power of a third is the same as the cube root of 8, and the cube root of 8 would be 2. And we discussed this in previous lessons where we said that this statement is true. So I just want to check that you know how to translate that. So let's go with this one. What is, we'll make it x to the power of, so we'll make it a, x to the power of quarter. I want you to write that in root form. And then for b, I'm going to say x to the power of a fifth. And for c, I'm going to say x to the power of a seventh. So what I want you to do is I want you to try and write this expression. So x to the power of a quarter, I want you to write it in root form or radical form for me. And then once you've done it, just say done in the chat. Just to show you what we're focusing on, we're doing these ones here. So this is an important idea that we know how to go between root form and surd form, or not surd form, radical form. Okay, so I think most of us are feeling okay. So this is the fourth root of x. And then what is the next one going to be? This is going to be the fifth root of x. And that is going to be the seventh root of x. Okay, so going between the irrational exponent, an exponent with a numerator and denominator, and going from that form into the other form is pretty easy. However, what do you notice about all the powers that I've given you so far? So a third, a quarter. Who would like to share what they notice? What have I done in all of them? What do they have in common for all the powers? And you can raise your hand or you can put it in the chat. What's in common with all those powers? They're all fractions. So perfect. Now, what is special about those fractions? Are there some types of fractions that I've left out? I'll give you a little hint here. Hearties, you are. That is looking good. Can you notice that the numerator is always 1? Clumelo, they're all raised. So 1 is the numerator, and the denominator is the number. Okay. Sometimes we say these are unit fractions. They always have 1 on the top and then stuff like that. Now, when you have a 1 on the top, it's very, very easy to go from the exponential form to the root form. Now, what happens if I give you something like this? So let me move this down. If I say to you, I've got x to the power of 2/3, and I want you to write that in root form, this is a little bit different. Notice how it's no longer 1/3, it's 2/3. So how do we write this in root form? Well, all we do is we focus on the 3, which is on the bottom, the 2 stays where it is, and we can rewrite it like this. So x to the power of 2/3 is the same as the 3rd root of x squared, which is a little bit weird, but basically the denominator is really important when we deal with rational exponents. So you notice that 3 is out here. So using this idea, I want you to write the following expression in a root form. So write for me x to the power of 4/5 in root form. In fact, I'll give you 2 of them here, 4/5, and we'll make this D and this E. And these are just quick little ones that we're starting with today. And just say done in the chat when you finished, so I know how things are going.
Mr. S.
Yeah.
Is asking, why is it a 3rd root? Why is the 3 there?
So the reason the 3 is there is that the 3 was at the denominator to start with. And so we're going to see the same thing happen here with x to the power of 4/5. This is the same as the 5th root of x to the 4. So notice how the 5 was here, and now that 5 is going to be outside. And then for this one over here, we're going to have, it's the 7th root of x to the power of 6. So notice how, so this slash is a divide, hey? 6 divided by 7. Give me a thumbs up if you're following what I'm doing. Give me a thumbs down if you feel like I'm going too fast, or if you feel confused. And again, be honest. There's no need to, we're all, it helps me gauge kind of how deep to go with this. Okay. Fantastic. Keep those votes coming, ladies and gentlemen. So if we then take this idea a little bit further, you'll notice that we can, let's try and do this. I want you to change each of these numbers from exponential form to root form. And there's 4 of them for you to do. And I'll come to various people to answer as we get going now, but I'm going to give you at least 3 minutes or so to do this. And there's one sneaky one, which is this one at the end. I want you to think about how you can handle that one as well. And then if you have any questions while students are working on these problems, you can raise your hand. Yeah, Khumelo, let's go to you. Hi, Khumelo.
Three and a half is your eyes. Okay, 3 and a half is 3. It's square root 3.
Yeah, perfect.
Yeah.
Perfect. Very nicely done. Awesome. So Melo is showing some definite knowledge there. So the power of half is the same as the square root of 3. If anybody feels like they've got this one in the bag, raise your hand and you can tell us the answer. Umta, let's go to you. Umta, how's it going?
Sir, I'm good, sir. Thank you.
Awesome.
Answer is 13 to the power of 3 rooted by given to the power of or rooted by 4.
Perfect. Yeah.
And so I was gonna ask the last one, right?
Hmm.
If it's the negative, can you change the numerator and the denominator, like switch them, and then it's gonna be a positive?
That's what I would use. I would use that power law that says that if you bring it below the line, it goes from a negative to a positive. I think you're getting very warm. That's like, it's a good sign. That's you're on the right track.
Thank you, sir.
Pleasure. Thank you for your answer. Let's go to Sibalwe. Sibalwe, have you got the answer for the third one? Sibalwe. Sorry, I might be saying it a bit wrong. Can you hear me? Sibalwe. Maybe we have some things there. This is going to be the 5th root of x to the power of 3. Now, the last one, someone gave us a very good, was it I think, who gave us a very good tip, where we realized that with exponents, if we have a negative power, if we bring it below the line, we can make this 1 over x to the power of 3 over 2. And from there, I want to see, can you convert that into a root form? Yeah, let's go to Mlungisi. Mlungisi, can you help us out there? I'm going to unmute you. What do you think this next step is going to be? I think maybe we're having a little bit of a unmuting problem there. No problem. Let's go to Annie. Hi, Annie. Can you hear me? Is it working? You just click a little button, Annie, and it's right there. Oh, I think that maybe the sound isn't working. No problem. We're having a few technical hitches. So the answer is going to be that. So you'll notice that the 2 was at the bottom. So the 2 was at the bottom, and that's why it's on the outside. So it's 1 over the square root of x cubed. And you'll notice this from laws earlier with exponents. For those who've done the earlier lessons, you'll notice that having a negative power, if you want to have a positive power, all that happens is that you bring it below the line and it changes from negative to positive. So if you came a little bit late, don't worry, the whole lesson is recorded. And so you can rewatch the first 15 minutes tomorrow. It will be on the website. But this little, can we hit mute all the level? I think there's a little bit of stuff going on. Just, let's have a look. And if I can ask you to, we'll unmute you as we go, but I think, there we go. Perfect. Okay, so that was the first part of the lesson. Don't worry if you're feeling a little bit lost. Like I said, that was coming on from previous lessons. We were building up to that. And so what I'm going to do now is I'm going to move on to like a new topic that we can all start together from scratch. So for those who are joining us for the first time today, we started talking about powers that were fractions a while ago. And so you can just watch those earlier lessons and the first part of today's lesson if you came late. All right, let's talk about something like this. Equations with rational exponents. This is an example of equation where the exponent is a fraction. So x to the power of a half equals 3. I would like to know, well, normally we solve an equation, we try to find x by itself and find the value of x that makes the statement true. Does anybody have a suggestion as to, well, first of all, in the chat, tell me what makes this equation harder than normal. What makes this equation difficult? You don't have to give me the answer, but what Tell me what you see makes it difficult in the chat. So the x, so 3 is a prime, the x bases aren't the same because there's an x instead of an actual number. I like that one. The x instead of an actual number, that's the x is unknown. So we're quite used to the x being kind of on the top some of the time. So it's a couple of different things. It's the fact that it's a fraction. And what we really want is we want it to be x by itself. And when x is by itself, x normally has a power of 1. Now, at the moment, what makes this difficult is it's not a power of 1. It's actually a power of a half. So let's look at this little help guide over here to see maybe we can use this little help guide. So it says, when working with equations, you must do the same operation to both sides of the equation. Okay, so whatever we do, we have to do it to both sides. That's nothing new. Get the variable with the fraction exponent on one side by itself. Okay, it's on one side by itself, no problem there. Get x by changing the fraction exponent to an exponent of 1. Now that's where the real work comes in. I'm going to suggest the following. See if you agree with me. Could I square both sides? I've done the same thing to both sides. If you think that's legal, give me a thumbs up. If you think that's illegal, give me a thumbs down. So do you think what I've done there is allowed? It looks to me like I've done the same thing to both sides. The way we say it is we say we've raised both sides to the power of 2, or we've squared both sides. Now, earlier in lessons 1 and 2, we spoke about the power law. If we have 2 powers next to each other, we just multiply. And so I think this is going to be x to the power of a half. Oh, I'm running out of space here. Let me. X to the power of a half times by 2 equals 3 squared, which is 9. And x to the power of a half times 2 is just going to be x. So x is 9 is the answer. So the answer to this question is x is 9. And we can actually test this to see if we're correct like this. Like if I said to you, what is 9 to the power of a half? Okay. A lot of you could say, well, I now know that 9 to the power of a half is the same as the square root of 9. And what's the square root of 9? It's just going to be 3, which makes sense because we started with 3. Yeah, let's go to Retabile. Retabile, what's your question?
So I wanted to ask, why did you, at number 1, at the equation, why did you power the both sides by 2?
Okay, that is a very good question.
I mean,
the reason I chose 2 is I wanted to end up with x to the 1 by itself. That's what I wanted to end up with. And if I multiply, okay, so if I multiply a half by 2 over 1, what do I get? I get 1. So I'm actually going to go because this is a really good question. So what I actually did, and I could even do it like this, I could say that I raised both sides to 2 over 1. And the reason I did that was because that was the only number that would give me a 1 at the end. So what I'm going to say in future is we raise both sides to the reciprocal of whatever the power is. Reciprocal is a fancy way of saying, like, flip the denominator and numerator around. Does that help, Retabile, a little bit?
Yes, sir, it does. Thank
Perfect.
you.
Let's see if we can apply this in another question. So take a screenshot if you want. I know that I need to explain this again, so don't worry if you feel a bit lost. But let's try this in another question. So let me grab, not number 2, I want number 3. So let's do this one. So Control C, Control V. Okay. All right. I want everyone to try and solve this equation for me using the idea that I just showed right now. And I'm going to give you a minute to 2 minutes to do that. If you are feeling very confused, then just raise your hand and we can have a bit of a chat. But for those of you who are feeling like you're ready to have a go at this, have a go at this. Yeah. Umta, let's go to you. Hey.
Sir,
Hmm.
on the, I don't know if it's left or right by you, but the side with the 8, right?
Yeah.
Okay, since I made it 8 to the power of 4 over 3,
Okay, so slow
can
down.
I use a calculator to solve for 8 to the power of 4 over 3?
Okay, so it depends on the question. Sometimes they say you can't use your calculator. Sometimes they say you can. For now, let's try and solve this without a calculator, but there was no explicit instructions to say no at this stage. Can you tell me though what you did? Can you talk me through what you did now that I've got you on the line here?
Sir, I said since x is to the power of 3 over 4,
Yeah.
right? I put that in brackets and then wrote outside of the brackets that it's raised to the power of 4 over 3. Since I wanted to cancel each other, since I wanted it to cancel each other, so I could be left with the 1. So I did it also on the right side.
This is great. Okay, so the real thing that was done here is you've taken the power that was there and you found the reciprocal and you've raised both sides to the power of that 4 over 3. And so what happened is that you have done this, and so this cancels out. And so you get x by itself on the side. And now we have 8 to the power of 4 over 3. Now, your question was, can you use your calculator or do you have to do it without? I want you to do it without your calculator for now. But I'm going to ask someone else to come online and tell me how to do it with the calculator. But thank you, Umta. That was great.
Thank you, sir.
Okay, who would like to tell me? Luyanda, let's go to you. What do you think we need to do to get the answer to this without our calculators?
Hi, sir.
Hey.
So I think we have to make the 8 a prime number. So
Okay.
I put in brackets 2 to the power of 3 in brackets, multiplied by 4 over.
So
and
raised
then,
to the power of 4 over 3. Yeah, perfect.
And then if then you're going to multiply the 3 power of 3 times the 4 over 3, and then the 3 cancels out, which you left with 2 over 4, which equals to 16.
Yep. Wonderful. Yes, yes, yes. Okay, so that is the answer is 16. Let's go to Bomb's question. Bomb, what's your question?
Hi, sir.
Hey.
Sir, I got the same answer, but then I didn't do it exactly like you did.
How did you do it?
I said since it was x 3 over 4 equals to 8. I said what's it? I said I did the egg part and I raised it to the exponent of 4.
Yeah, yeah.
And did it to 8. Then
It sounds like you
then
can get there.
Sir?
Yeah, no, that sounds like you're on the right track. It sounds like you will get to the correct answer, and there are a couple of ways to do this. So as long as you got there using legitimate steps, you'll get full marks for this question too.
Okay, sir.
Perfect. Perfect, man. You know, there's always like that in math. There's always a couple of ways to do things. All right, I did 3/4, that did that one. Okay, let's not get that one. Let's do these two before we go to a, well, let's do number 2 here. 2/3. Well, let's not do that one. Let's do this one. I want you to find me the answer to this question. There's a slight difference. So you're solving this equation. See if you can get the answer to this one.
Keep going, guys.
It's almost break time. We've been winning at life in this one. And if you're feeling very generous, maybe you can give us a top tip in the chat as to what you think your first step would be. I'm curious to know from the people of the class what you think your first step should be, because there might be some debate. I'm interested to know what maybe some people's first step will be different. So Atule, we are trying to solve for x in this question. So that is the keyword. And the x is this thing, but the x has got a power in this question. All right. So I agree with Sakile and Spokazi that the 3 is a little bit new. And if we go back to the beginning of the lesson, we really want the x by itself. And so the way that we get the x by itself is we divide both sides by 3. And so that's a very good first step, because that means we get left with this. And that looks a lot more like the question we did previously. But now we're still not done. You still have to solve this question for me. Once you think you know the answer, pop it in the chat, and then I can see where the people are at. Keep those answers coming. This is the important bit. You have to ask yourself, how can I get the x to be x by itself? I think you raise both sides to that. And then these are going to cancel. And that is that. X is 64. Okay, we've done really well. If we look so far today, we've talked about how to go between exponential form and root form. And we've also spoken about how to solve equations with rational exponents. Okay, don't worry, Kokela, we're going to do some more after the break. We're not done practicing, but we do know that we need a break. Because we've been sitting for half an hour, we've been using our brains. And so what I want everyone to turn their cameras on, and I want you to stand up with me like this happy chap, and we are going to do some stretching. Okay, so we are going to, let's just quickly stop the share here and stand up, everyone. If you can, please give shout outs to the most enthusiastic stretchers. Oh, and what we're going to start is with a nice shoulder roll just to relax our shoulders. We've been thinking hard. Just roll your shoulders back. and feel your body just go, that is nice.
Please join us for the stretch, guys. Put on your cameras. Let's see your lovely faces.
And then roll your shoulders forward. And I promise you this will serve you well in the second part of the lesson. Then stretch your neck out. So stretch that out to the left. Stretch it to the right.
We have so many cameras on today. I am so loving this participation.
Okay, and then shake it out. Shake it out like, jazz hand. How's it go? Or how do jazz hands go?
I think like this. I forgot. How did it go?
Shake it out. Just shake it out. Yeah, there we go. Get those hands nice and loose. There we go. Oh, doesn't that feel good? The drama teachers know how to do this stuff. This is like, it's the way to go, man. This is the way to go. All right. And then let's do one more stretch. Let's take arms across, shoulder stretch like this. Oh, doesn't that feel good? And then the other side. Okay, and shake it out one more time. So you may think I'm a little bit of a nutty professor, but I promise you that just letting your body relax for a bit makes a huge difference. It's not easy doing maths and concentrating for this long. And by sort of treating our bodies with respect and just giving ourselves some time to recover, it really helps our productivity. Okay, here's the little puzzle problem before we go back to class. Can you solve this? How much is a cat plus a raccoon plus a bird? And you can put your answers in the chat. I look forward to the replies. Using your mathematical logic, can you answer this problem? Sino, I think you're onto something. I think you're onto something there. So Sino has helped us out there. You can see clearly this is a 5. I agree with you, Kumar. So this is 15. And then what is a raccoon going to be? Something minus 15 is 40. I think this has to be 55. Because 55 minus 15 is 40. Huh? Be careful. So what's your final answer going to be? So it's all pluses. So 5 plus 55 is 60. 60 plus 15 is 75. Yes,
well
Renee.
done, everyone.
So just a quick question. Those who have been doing these problems for a while, does it get easier each time? I know there's a lot of new students here today, but they might be finding it quite tough. But for those who've done these, like in the previous lessons, are they getting easier? Just let us know in the chat. Okay. Because these are called simultaneous equations, essentially, and as you do more of them, you kind of figure out how to pop the one bit out into the next bit. And yeah, awesome. Okay, really proud of you guys. You've done really well. Let's return back to our problem. Okay, now here is something a bit different here. So if I say to you, x to the 2/3 equals a quarter, there's something a little bit different about this question, which I want you to watch out for. Can you see that the numerator is even in this question? So the numerator is even. Up until this point, I have deliberately avoided having a numerator in the fraction which is even. So like, if you look back to the previous questions, you'll notice that I had 3/4. So the 3 is it's an odd number. And you'll notice that I had, what did I have down here? I had a 1/3 where it was an odd number. when you have a situation, sorry, you must be getting dizzy there. When you have a situation where the numerator is even, your exponential equation is going to have two answers. Okay, it's going to have two answers. And I just want to show you how that's a little bit different. When you say it's even, what I mean is the number, if you look at a fraction, there's two parts. There's the numerator, which is on top, and the denominator, which is on the bottom. So in this equation, the numerator is 2 and the denominator is 3 in the power. So just give me a thumbs up if you understand the difference between numerator and denominator. And what I'm saying is when the numerator is even for this type of equation, you're going to have two answers. You're not just going to have one answer anymore. But then the question is, how do you get the two answers? Okay, so the first step is that you raise both sides to the reciprocal of the power. So I'm going to just do this. So we're going to do that. Now that feels very familiar to what we were doing before. Nothing too exciting there. But now when we apply this to both sides, what we're going to do in the next step, in fact, let me do a step by step. If I write x to the power of 1 on the left-hand side, are you guys all with me how I got x to the 1? Essentially, these ones canceled out. Give me a thumbs down if you don't understand. It's important that I kind of am with you. You're with me here. Okay. Now, on the right-hand side, because you are, if you look at this 2 over here, let me go back here. Because this 2 is like a square root. You know, when you take the square root of something, there's a plus and minus that you get. The same thing happens here. You get plus minus 4 to the power of 3 over 2. Now that, there's a couple of ways you could learn this. The one is to say when you have a numerator is even, you always put a plus minus in for your answer. The same way, if I said to you, what is the square root of 9? It turns out there's actually two answers. There's plus and minus 3, isn't there? Do you get what I'm saying with the square root of 9? Again, just give me some feedback. Does everybody understand the square root of 9 is actually can be plus or minus 3? If I said to you, what is the, okay, awesome. Now, this isn't actually that bad. So the only thing I've done different is I've recognized that the numerator is even, and now I raise both sides to the power and I put plus minus in. How does the next step go? Well, all I do is I'm going to write 4 as 2 squared, because I know 4 can be written as 2 squared. I'm going to cancel out these 2's. And my answer is going to be plus or minus 2 to the power of 3 or plus or minus 8. So let's go back to the beginning. What did I spot? I first looked to see that the numerator was even. The top part of the fraction. The top part of the fraction is even. Then I did the normal thing. I raised both sides to powers, but then I put this extra plus minus in. And at the end, it just meant I had 2 answers. The same way that I have 2 answers when I have plus or minus for a square root. Yeah, Tando, what's your question? Let's go to you. Hi, Tando. You can unmute yourself.
So at the 2, there's a square root. Where does it come from?
With the 2, where's the square root? So if you look at this 2 over here, that 2 divided to the power of a half is the same as a square root. Do you remember earlier in the lesson when we said x to the power of a half is the same as a square root? So it's this 2 over here, which is doing that. So see now I said when the numerator is odd, we only have one answer. When it's even, there will always be two answers, plus, minus. Yes, perfect. Let's do another example, because I think if we do another example, a lot of the uncertainty will go away. So take a screenshot if you need to, and then let's go on to the next one, and you'll see an example, and I promise it'll make much more sense. Okay, now, what I want to do, let's actually find one that is, can I find one like that? No. Okay, let's do this one then. This is a bit of an upgrade. So we are going to focus on, we're going to do question 2 together. Okay, so we're going to do question 2. However, I need to solve this one. This looks a bit weird. And what I'd like you to do is I'd like you to change this from root form into exponential form. So first of all, I'd love someone to come online and tell me, how do I go from the 5th root of x to the 4 to exponential form? Who would like to share that first step?
We have a hand from Umta, Mr. S.
Okay. Umta, how would you change the first step? How would you begin to solve this?
So firstly, I don't know if that's a -4 or just a 4. I
That's a
can't see
normal
properly.
4.
It's a normal 4. So I think you'd say x is equal to the power x is equal to the power of 4/5, if I'm correct.
Okay. Perfect. So we change.
256.
Okay. Thank you, Umta. That's perfect. We're going to stop there for now because I want to give some more time to do this. So step 1 was to change from root form into exponential form. Now I want to ask the class, is there going to be one answer to this equation, or is there going to be 2 answers? Azile, would you be willing to tell us one answer or 2 answers? What do you think?
I think 2 answers,
Why do you think it's 2 answers?
because the numerator is an even number.
Yes, I like it. Okay, that is great help from the class. I want everyone to try and find the answer now. Go from that point. Okay, Asimbonge, what we're going to do, don't worry, we are building up here, and the good news is that there's recordings that you can go over. If you look at what's happened so far, the big problem in our life is that the x is to the power of 4/5. I'd really like it to be x to the power of 1. Ask yourself what I need to do in order to get x to the power of 1 on one side. That's my tip I'm going to give you. Jamina, let's ask you, what is your question? Do you have a question, Jamina?
And
Can you hear me?
yes, I don't understand, sir.
Okay, let's do this together. Are you happy with the 5/4 as the power on both sides? Do you understand why I'm choosing 5/4?
Yes.
Okay. Would you agree with me that because the 4 is an even number, I'm going to put a plus minus over there? Because the plus minus is for the 2 answers to happen. Are you with me?
Yes.
Okay, so now if you can use your calculator, you could put this straight into your calculator. However, if you didn't have your calculator, what you would really want is to break the 256 down into prime factors. But for now, because of time today, I'm just going to use our calculators, and you should get the answer is plus or minus 1024. So you can type this into your calculator, 256 to the power of 5/4, and you'll get 1024. If you want to see where that answer comes from, we can also break the 256 down further, but for time-wise, I'm going to leave it for today. So, you may have to use, normally you would be allowed to use your calculator in this particular type of step. I would imagine 256 is a power of 2. It feels like, I know 64, if I double that, 128, then 256, but this is getting a bit big for just, you could use the ladder method, I guess. Oh, and to also said it's 4 to the power of 4. So that could also help us out. Yeah. So we could replace that, and that's perfectly good. All right, let's try and squeeze in one more question, and then, because we also want to do a poll, but I like what I'm seeing. Or maybe let me ask for questions while students are, in fact, let's just do this last one here. So last question of the day is going to be this: x to the power of a half is equal to 7. What is the answer going to be for that? And then anybody who's feeling confused, you can ask a question. Otherwise, I want to see your answer in the chat. And then also we're going to share a poll with you in a moment to get some feedback from you about how you felt the lesson was today. But we've still got some time, so let's see how it goes. So Lile is saying that if you press 256, then equals, then shift to fact, you get some assistance with finding the prime factors. Thank you. Keep those answers coming, guys and girls. Sibabawe, let's go to you.
Good afternoon, sir.
Hey.
For number 2,
Yeah.
I broke down my 256 to the 2 to the power of 8. So
Yes.
I wanted to ask, if I use it on the exam, will it be correct, or will I be marked down?
No, it's perfectly fine. So all that happens is you will get essentially the 8 multiplies by the 5, and you should get 2 to the 10, which is the same. Is it 2 to the 10? Have I made a mistake there? Yeah, I think it is 2 to the 10, which will then give you the same answer.
Oh, okay. Thank
So
you,
it's
sir.
completely fine. Okay,
I just wanted to confirm. Thank you.
Yeah, all good. No, that's why we're here. So with this one, there's only going to be one answer because the numerator is an odd number. And so we get x is 49. Level, could we please put the poll out to students if they could help us by giving honest feedback about how they found the lesson in terms of pace? There's been a question.
Will do, Mr. S.
Cool. How do you find prime numbers on a calculator? We'll go back to that in a future lesson, but one of the students said in the chat, let's have a quick look where that was. Because it depends on what calculator you use. You can just press 256, then equals, then shift to fact is what was said. And so you can try that out, but it depends on what calculator you have. So I'll just put that comment in the thing there. Thanks, Rile.